In this video, I'll give a quick overview of our implementation of the Huffman coding algorithm, which is a popular algorithm for lossless data compression. So our implementation consists of three main classes. The first one is the file manager, which is a utility class for reading in files, the Huffman tree itself, and within the Huffman tree we also have Huffman node, which is an inner class. So for how this actually works, we'll begin in our entry point main.java. The first thing we do is instantiate a new file manager and pass in the file we want to read. The file manager just takes the file and it reads it in as a byte array with read all bytes. Once we have our file manager, we run this method on it called getFrequencies. And getFrequencies is going to return a sorted map containing how many times each byte appears in the file. So you can see our return type is a map of bytes and an integer, which is the frequency of that byte. Once we have that, we can declare a new Huffman tree and we pass in these frequencies that we found. So inside the Huffman tree we have our byte frequencies, and we're going to separate them out into bytes and frequencies. And the constructor then with the loops here, it's going to create a node for each of the bytes and adds them to a priority queue. So you can see we have this first loop here. The idea here after we've created the priority queue is to initialize the priority queue. That's what the first loop does. It iterates over the bytes array, which contains the unique bytes in the data, and then for each byte it's going to create a new Huffman node with the byte and its corresponding frequency. So you can see we're creating a new Huffman node, passing in bytes I and frequencies I, and then the second loop is where the Huffman tree actually gets built. So the idea with Huffman coding is to remove the two nodes with the lowest frequency from the priority queue, create a new node that has those two children, and then it's going to have the sum of their frequencies as its frequency. So you can see we're doing that here. So we're taking x.y as the children, and the frequency is going to be x.getFrequency plus y.getFrequency. Once we've done that, we add that node back into the priority queue, and this process is just repeated until there's only one node left in the queue, which is going to become the root of the Huffman tree. So back to our priority queue, we have this comparator in here. We have this to make sure that the priority queue is going to be a min heap based on the frequency of the nodes. That just means that the node with the smallest frequency is always going to be at the head of the queue. So in this way, it creates the tree from the ground up. So setParents then traverses the tree and it sets the parent node for each node, because when you're building the tree from the bottom up, you can't know the parent node in advance. Down the bottom then we have an implementation for the Huffman node itself. So it uses this generic U for the type of the element. The element can either be a byte if the node is a leaf, or it could be null if it's an internal node. The frequency then, as we said, is the number of times that the byte appears in the file if it's a leaf, or it'll be the sum of the node's children if not. So two more methods worth mentioning then before we show this actually running. We have encode and decode. Encode creates a string which represents the Huffman code, and then it just uses a bit set to turn the string into a series of bytes. Decode then recreates the original byte array by reading every bit in the file and traversing the tree accordingly to get the right leaf. So now let's just show this running. Our test file is test.txt. Let's run. And our printout will show the tree as it's built. And we should be able to look now and see, if I refresh the files, that we've got this test.txt.bin. So if I open up my files here, okay, so we've got the original test.txt, which is 460 bytes in size, and our compressed one. Sorry, our compressed one then is only 245 bytes. So our compression works. Hopefully this video was informative. For more detail on our implementation, please have a look at our Google Doc. Thank you for watching.